So good day everybody. For today's video, I'll be discussing you how to solve this problem. We have this problem. An aluminum rod is rigidly attached between a steel rod and a bronze rod as shown in the figure. Axial loads are applied at the positions indicated. Find the maximum value of P that will not exceed a stress in steel of 140 MPa, in aluminum 90 MPa, or in bronze of 100 MPa. So I already written here our given and our unknown, which is the P. So in our figure here, I already cut each section. So we have 3 sections all in all, 1 in each rod. So we have section AA here, BB, and CC. So in section AA, in bronze, got it here. So I cut it here, so you can see here. Then we have a load going to the left. So since it's going to the left, we need to have a load opposite to that. So we have here the load of the bronze. Next, for section BB, here, we have a load of P and a 2P. Here, as we can see in the figure, since 2P is greater than P, we need to have a load opposite here, opposite to this, which is this one, the load aluminum, for aluminum. Then for section CC, we can have this. I cut it here, so as you can see, it was cut here. And we have a load for P, P, and 2P. Since 4P is greater than the 2, then we have to have a load opposite to this. So I have written it here, drawn it here. We have load steel. Okay. Solving this, we need to solve it by using this formula. Summation of forces in the x direction is equal to 0, assuming that our unknown is here, it's positive. Assuming that going to the right is positive. Since we are finding this, so we need to follow the direction of this. Okay, so we have the load of the bronze minus 2P is equal to 0. Then, so we have this answer. So our load of the bronze is equal to 2P. For this section here, for BB, we have summation of forces, in the x direction is equal to 0, assuming that going to the right is positive. So we have the load aluminum plus the P, this one because it's going to the right, minus this because it's going to the left, minus 2P is equal to 0. Then find PAL, or the load in aluminum. So now we got the value for aluminum. Next, for the steel, for the load of steel, same process, summation of forces in the x direction is equal to 0, assuming that going to the left, right, is positive. So we have the load in steel minus 4P plus P minus 2P is equal to 0. Then we have this, transpose all of this at the right hand side. We have this one, and also this one. We will be solving for our P. What is the value that is here? Maximum value of P that will not exceed a stress in steel here, which is indicated in the given. So in order to find that, we need to use this equation, which is stress is equal to P over the area. So this is the unknown, the P. So P is equal to the stress times the area. So this is our equation. For this section, or for the bronze here, we have this PBR is equal to the stress of the bronze times the area of the bronze. Okay, we have the value of the load in the bronze, which is equal to 2P. So we're going to write 2P is equal to the stress of the bronze, which is 100 MPa, times the area of the bronze, which is 200. So we got 20,000 divided by 2, we got P equals to 10,000 Newton. Don't forget the unit. For the aluminum, we got P aluminum is equal to the stress aluminum times the area of the aluminum, which is equal to, so our load in aluminum is just equal to P. So P is just equal to our stress in aluminum, which is 90 times the area, which is 400, 36,000. So that is our value of P. Now, for this section, or for our steel, we got this equation, area steel. Okay, for our load of the steel, we got here our 5P. So replace it by 5P is equal to the stress, which is equal to 140 times the area, 500. Multiplying it, okay, divided it by 5, we got P equal to 14,000 Newton. Sorry, I forgot the unit. Okay, now we got each value of P. So in order to have a safe axial load, we need to disregard this and this. Okay? Because if we choose this, which is the largest among the three, there's a tendency that the bronze will break and the steel will break, because it is more than the amount of load they can carry. So in order to have a safe axial load, we need to have a load of 10,000, less than 10,000.